Look up on a clear night, and it all looks still, frozen, safe. But every one of those points of light is a machine of destruction, and a few of them have Earth's name on the list. Some threats we'd see coming years in advance. A mountain of rock we could maybe, just maybe, push aside. Others would arrive with no warning at all. A wave of radiation already halfway here. A star that shouldn't be moving. A thing so dark you'd only know it existed by watching everything else start to fall the wrong way. These are the ways space could end us. 7 of them. And I've ordered them from the one we could fight, all the way down to the one we could never even see coming. Number 1, the asteroid. We start with the one you already know, the one that has a Hollywood movie and a bright side. 66 million years ago, a rock about the width of a city, maybe 10 kilometers across, fell out of the sky and hit what's now Mexico. It didn't just kill the dinosaurs, it punched a hole in the planet, threw a curtain of molten debris around the entire globe, and blotted out the sun long enough to starve roughly 3 out of every 4 species on Earth to death. The impact released more energy in a single second than every nuclear weapon ever built, detonated at once. And here's the strange comfort. This is the friendly one. It's the only threat on this whole list we can actually see coming, sometimes years ahead. And in 2022, we proved we can nudge one off course, slamming a spacecraft into a harmless asteroid just to move it a few feet. A rock, at least, gives you time, but the next one doesn't. It's already left its source. It's traveling at the speed of light, and if it's aimed at us, we'd get about 18 hours. Number 2, the solar storm. That 18-hour warning belongs to our own star. The sun is constantly flinging clouds of charged particles out into space, and every so often it launches a big one straight at us. In 1859, one arrived. They called it the Carrington event. Telegraph wires, the internet of their day, sparked and caught fire. Operators were shocked by their own equipment. The northern lights burned so bright over the Caribbean that people woke in the middle of the night thinking it was dawn. That was with 1859 technology. Do the same thing to a planet wrapped in power grids and satellites. And here's the part that should worry you. The giant transformers that run our electricity can take years to build and replace, and a severe storm could cook hundreds of them in an afternoon. No explosion, no crater, just the lights going out across a whole continent and not coming back for months. And this isn't some distant maybe we're still waiting on. In 2012, a storm powerful enough to do exactly that crossed Earth's orbit. We simply weren't standing in that spot when it swept past. And remember, our sun is a small, quiet, middle-aged star. So what happens when a giant one dies? Number 3, the supernova. When a star far bigger than the sun runs out of fuel, it doesn't gently fade. It collapses and rebounds in an explosion so violent that, for a few weeks, that single dying star can outshine every other star in its galaxy combined. 100 billion suns, beaten by one. It's one of the most beautiful things the universe does. It's also one of the deadliest. If a star exploded close enough to us, somewhere within about 100 light years, the danger wouldn't be heat or light. It would be radiation. That wave of energy could strip away the ozone layer, the thin sheet of gas that works as the entire planet's sunscreen. And once it's gone, the sun's own ultraviolet light starts sterilizing the surface, killing off the tiny ocean life that the whole food chain is quietly built on. The good news? The nearest real candidate, a bloated red giant called Betelgeuse, sits around 600 light years away. When it finally goes, and one day it will, it'll simply hang in our sky like a second sun for a few weeks, close enough to admire, far too distant to hurt us. A supernova hurls its fury outward in every direction, so distance protects us. But there is a way for a star to die that doesn't spread out at all. It aims. Number 4, the gamma ray burst. This is the single most powerful explosion in the universe since the Big Bang itself. When certain giant stars collapse, or when 2 dead stars slam together, the dying object fires 2 narrow beams of pure gamma radiation straight out of its poles, like a lighthouse. If the lighthouse could sterilize a planet, in just a few seconds, one of those beams releases more energy than our sun will radiate across its entire 10 billion year lifetime. And because all that fury is focused into a beam instead of a sphere, it stays deadly across distances that make no sense, thousands of light years away, and still lethal, as long as you happen to be standing in the line of fire. If one were pointed at Earth, you'd never feel the radiation itself. You would see a flash in the sky, and then, over the following months, half the ozone layer would simply be gone, and the planet would quietly begin to die. Some scientists think this has already happened once, that a gamma ray burst helped trigger a mass extinction on Earth around 445 million years ago. There's even a candidate out there right now, a whirling pair of stars called WR104, roughly 8,000 light years away, that some researchers believe may be angled unnervingly close to our direction. Every threat so far needed a trigger, a collision, a collapse, a blast. The next one needs nothing at all. It's simply on its way, and it's an entire star. Number 5. The rogue star. We tend to picture the stars as fixed, painted permanently onto the sky. They're not. They drift. And some of them are drifting toward us. Right now, about 62 light years away, a dim orange star called Gliese 710 is heading in our direction. In roughly 1.3 million years, it won't hit us, but it will pass straight through the outermost shell of our solar system, into the Oort cloud, the vast reservoir of 1 trillion frozen comets that wraps around everything we know. Picture a bowling ball rolling slowly through a cloud of loose marbles. It doesn't need to strike the Earth, it just needs to knock those comets loose, flinging a slow rain of them tumbling inward toward the inner planets, a bombardment that could stretch on for millions of years. And there is nothing you can do about a star. You can't deflect it. You can't destroy it. You just watch it grow brighter in the night sky, century by century, until it burned brighter than anything else up there. And if all of this sounds too far off to feel real, it's already happened. Around 70,000 years ago, a small red star brushed the edge of our comet cloud while our ancestors watched it drift past from below. Every danger so far has come from the outside, something arriving. The last two have been here all along, and one of them you trust completely. Number 6. The sun. The single object that gives us everything, every sunrise, every harvest, every warm morning you have ever had, is also going to be the thing that ends us. Not maybe, certainly. Our sun is about halfway through its life, and as it ages, it is slowly, steadily getting hotter. In roughly 1 billion years, long before it does anything dramatic, it will grow just bright enough to boil the oceans off the face of the Earth, turning our blue planet into a scorched, dead twin of Venus. And then, around 5 billion years from now, as it finally burns through its fuel, it will swell. It will balloon outward into a red giant so enormous it swallows Mercury, then Venus, and reaches out toward the blackened cinder that used to be our world. Everything on this list until now has been a could, a maybe, a single roll of the cosmic dice. This one is the only guarantee, the one appointment none of us can ever cancel. But at least the sun is honest about it. It's right there in the sky. We can watch it, measure it, count down the years with our own instruments. The final way space could destroy us offers none of that. It gives off no light. It makes no sound. And you would only know it had arrived when the planets themselves began to move the wrong way. Number 7. The rogue black hole. Somewhere out there, a black hole is drifting with no star to mark it. The leftover corpse of a giant that died long ago, wandering the galaxy completely alone and completely invisible. Our Milky Way is thought to hold around 100 million of them, and every single one is dark. We can't photograph them. We can't catch their light because they have none. In 2022, astronomers confirmed the very first one for certain, about 5,000 light years away, roughly 7 times the mass of the sun. And the only reason they found it at all is that its gravity bent the light of a distant star passing behind it, like spotting an invisible figure only by the way it warps the wall at its back. Now picture one of them drifting silently toward our solar system. There would be no warning, no flash, no glow, nothing in any telescope to point at. You would notice it the way you'd notice a hole opening in the floor of a pitch black room, not by seeing it, but by the things that start to fall in. Orbits would stretch, the planets would begin to wander, Earth could be slung out into the freezing dark between the stars, or dragged down toward a place where light itself can't climb back out. And by the time we truly understood what was happening, there would be nothing left to do about it. We began with a rock we can see coming from years away and can even push aside. We end with a thing we cannot see at all, cannot stop, and cannot outrun. The universe, it turns out, saved its quietest weapon for last. So the next time you look up and the sky looks calm, remember, it isn't. It's just slow. Every one of these is out there right now, some of them millions of years away, one of them ticking quietly down inside our own star, and one of them invisible and drifting on no timeline at all. If you made it this far, comment black hole, so I know you survived all 7. Leave a like to tell the algorithm you're still here, and if you want to know which of these could actually happen within your lifetime, that's the next specimen waiting in the archive.